or anything you have not understood? It's okay. Now, anyway, this is the 4th or 5th class, right? Okay, and
Yes, sir.
yeah, we will keep one class. Okay, and only for the doubts tomorrow or anything. Tomorrow you'll be free.
Tomorrow, what time, sir?
फ्री हो ना कोई भी टाइम हो सकता है फ्री है ना अब क्या करना है
हाँ सर
yeah, so 1 hour we will have a session for the doubts and then anyway okay we'll start this and we'll go through the topics and here last class so we started with the alkanes okay and the prominent peaks what are the characteristic peaks that we discussed alkanes and next one is that how to differentiate between the straight chain alkanes and the branched alkanes that also we discussed in the mass spectrum. Next one is that alkenes these are the that is examples also we have seen, and next one cycloalkanes also we have discussed, and then alkenes how they undergo the fragmentation and what is the prominent peak you will observe in the alkenes that also we have discussed. And in the alkenes we see that McLafferty peak or allylic peak, that is M by Z value 42 is the very prominent peak that with this you can easily identify where it is allylic cation. And the mass spectrum if you see this is the allylic cation, this allylic, and sometimes alkenes also undergo the McLafferty rearrangement. McLafferty rearrangement is formation of okay olefin, that is one is olefin will be forming and another one is that carbocationyl that is will be forming. And in this case the pentene, one pentene or whatever it is, so in this case if you see that there is a McLafferty rearrangement and as well as form allylic cation formation, both will be there. You can here you can see that there is a olefin, that is neutral molecule is eliminated and you have the stable allylic cation. So and this you this will be appearing as a most abundant ion or a prominent peak in your mass spectrum. Okay, allylic cation. With that you can identify M by Z value. M by Z value if you have okay that is a 42, then you can say that it is an allylic cation. Allylic cation generally appears with or occurs with alkenes. So this is a one pentene. You can see that this you have M minus 15. So here CH3 will be removed and M minus 15 you have the cation. Once if this is removed, so that means from the mass that is 70. Okay, from M by Z value that is a molecular ion peak. So total molecular ion peak will be of M by Z value that is at 70 it appears. Next one is that you M minus 15, that is a cleavage occurs here, and then CH3 will be removed as a radical, then you'll have the cation fragment ion. So that is M minus 15 you have there. And then next one is that here okay cleavage occurs here, and the remaining one is this cleavage occurs and it will be removed as a CH2 double bond CH2 okay, and as a olefin and then you will have the allylic cation that is M minus 28, that is M by Z value 42. This is the prominent peak and we'll consider as a most abundant ion okay, and this is a characteristic peak and we collect for the cation, that is allylic cation. Next one is that here you can see M by Z value 41. This is okay, and this is removal of okay CH3 single bond CH2 okay, CH3 single bond CH2 okay, and that is M by Z M minus value 29, it will be removed. And again here also it is allylic cation will be formed. Here also allylic cation, that is because of okay McLafferty rearrangement. You can see that McLafferty rearrangement this is, and this is there is no okay here there will be the McLafferty rearrangement, there will be migration of one hydrogen ion from the gamma carbon atom. This is a gamma carbon atom, one hydrogen ion migration will be there. And whereas in here in this case okay, this case M by Z value 41, so there won't be any migration of one hydrogen, and directly CH2 CH3 as a radical it will be removed. And whereas that's why you have the M minus, that is 9. The mass of CH3 and CH3 single bond CH2 is, the mass is 29. So that will be removed. Whereas here one hydrogen from the gamma carbon atom will be transferred. Then you will have the CH2 and CH2, that is as a neutral molecule will be removed. The mass of this CH2 and CH2 is M by Z value is 29. So that's why you have the McLafferty-Fick. McLafferty-Fick is this one, M by Z value 42. So this is one pentene we have already discussed. Again, we are going through it. So next one is this. You have here, this is 2-pentene. Okay, this what we discussed is the terminal alkene. So you should be able to differentiate whether it is a terminal alkene or whether it is a 2-alkene, that is 2-alkene or anything. So coming to the terminal alkene means the double bond at the terminal. Okay, this is terminal. Double bond is at the terminal chain. So at the end of the chain you have, that's why we call it as a terminal alkene. So here it is not a terminal alkene. So now you can see that in here, okay, you have the characteristic peak, that is McLafferty rearrangement. Okay, that is M by Z value we have seen here, M by Z value 42. This is the most prominent peak. Understood here? M by Z value 42 is most prominent, 100% abundant. And at the same way, here also we have M by Z value 42, which shows that is here you have a McLafferty rearrangement. And then the most prominent peak here, it is that M minus 15 value. Okay, M minus 15, that is M by Z value by loss of methyl group. By loss of methyl group. So you have the 55. So M by Z value 55. Yeah, this is the most abundant ion. Now you can differentiate whether it is a terminal alkene or not. So if it is a terminal alkene, and then M by Z value will be prominent. Okay, M by Z value will be prominent. And then if it is not a terminal alkene, so the M by Z value, that is 42, that is which represents McLafferty fragment, will become less abundant. Okay, other will become more abundant. Here M minus 15 peak will become more abundant. Understood? So this is,
yes, sir.
This is anyway molecular ion peak. So these two you should be able to differentiate whether it is a terminal alkene or not. How you differentiate? In if it is a terminal alkene, M by Z value 42. Yeah, M by Z value 42, that will be more prominent peak. And then if it is not a terminal alkene, then okay, the McLafferty fragment, so it will become less abundant and other fragments will become more abundant. Okay, so this is what happens in with the alkenes. So next is cyclohexene. Okay, in the cyclohexene you can say that again here M loss of CH2 CH2. Okay, so that is you have M by Z value 54, and then you have the here again loss of CH3. Okay, M by cyclohexene, so loss of methyl unit, M by Z value 67. So both you can find out loss of cyclohexene. You can find out loss of M minus 28 peak and M minus 15 peak. So these are the characteristic peaks of one is allylic cation is a characteristic peak. Another one is M minus 28. Another is characteristic peak, and M minus 15, that is another characteristic. So this is here you can see that here this is a molecular ion peak. Okay, molecular ion peak, cyclohexene molecular ion peak. So then that is M. This value is 82. 82 minus 15, you will get the 68. That means 15 represents CH3 here. Okay, and then here M minus 28. M minus 28. So 82 minus 28. So 28 molecular weight is represents the normally it represents. We have already discussed this. Okay, exact molecular weight you calculate, and M minus 28 So it represents CH2 double bond, CH2 in neutral molecule. So these are the characteristic peaks of the alkenes, whether it is a cycloalkene or whatever. Okay. So molecular, anyway, we have discussed the molecular ion peaks anyway. They are okay. So they are visible. So here you can see that say alkenes, molecular ion peak. So prominent it is. It is visible, not like here alkanes, whether it is a branch straight chain alkane or branched alkane. Okay, but in cycloalkanes, the molecular ion peak will be visible. But here for alkenes as well, anyway they are visible. And sometimes here in alkenes, we know that we have already discussed that they undergo the McLafferty rearrangement as well as they undergo the retro-Diels order reaction. McLafferty rearrangement we have seen. Okay, McLafferty rearrangement we have seen, and retro-Diels order reaction also they undergo. So this is limonene, how it undergoes the so limonene, and it undergoes the retro-Diels order reaction. So Diels order reaction is that we have discussed Diels order reaction. Diels order reaction, a olefin combines with the butadiene and forms cyclohexene. Okay, olefin combines. Olefin means olefin that
CH2.
CH2 double bond CH2 combines with butadiene. Okay, and gives you cyclohexane. Cyclohexane, that is Diels order reaction. Retro Diels order, opposite to that. Okay, cyclohexane undergoes cleavage, and you will get a olefin butadiene. This is limonene, how it undergoes the retro Diels order reaction. So that is the thing you have. So here you can see. Okay, so this is retro Diels order reaction. Retro Diels order reaction, cyclohexane undergoes. Okay, so here you have cyclohexene that is undergoes the cleavage, that is a molecular ion of cyclohexene, and undergoes the retro Diels order reaction, and you have a olefin, it gives a olefin and butadiene fragment ion by Z value 55. So how that's how we got the peak here. M by Z value 50, okay, 55 peak will be there, that is M by Z value. Cyclohexene. So M by Z value 55, this peak also will get, or that also undergoes the this one cleavage, and we'll get other prominent peaks. Okay. So alkynes, next coming to the alkynes. So alkynes, so here the prominent peak for the alkynes, terminal alkyne or whatever it is, the prominent peak is this. Okay, M by Z value. Okay, so propargyl, okay, cation, propargyl cation, that is M by Z value, especially in case of terminal alkynes. So propargylic acid, this peak, okay, this peak is prominent, very prominent peak. Okay, so here you can see that it is terminal alkyne. One of the methyl group is cleaved off, okay, one as radical, and then you will get the propargylic acid. Okay, so this is the prominent peak for the terminal alkynes, that is unsaturated, which are having the triple bonds, alkynes, and M by Z value 39. Okay, so you will have the sort of characteristics. If you see that, you'll have a strong anyway molecular ion because we have a triple bond, and they'll be stable. And then M minus, okay, M minus value also is M minus 1 peak also is observed. M minus 1 peak means one mass unit will be less than the molecular ion peak. Okay, and that means the terminal alkene, here you have CH. Okay, here you have the CH, and one of the hydrogen will be removed. Okay, one of the hydrogen will be removed, or so that is, or here CH is there, that is one of the hydrogen will be removed from here. So one mass unit will be lesser than this is a molecular ion, and from this molecular ion, so one hydrogen on mass unit will be removed. You will get the M minus 1. Okay, and anyway we have seen that resonance stabilized propargylic acid you will get, that is M by Z value 39. Okay, this is a fragment, stable fragment you will get, like allylic cation, how we are getting. See, this is propargyl cation you will get in the alkynes, that is the prominent peak, most abundantly available fragment for the alkynes. So this is one pentyne, okay, one pentane. So you can draw the structure of one pentane, and you can find out here. You can see that M-1 is very prominent peak. So pentane molecular peak, that is ion peak mass, is that M by Z value 68, M by Z value, and this is M-1 peak. And then you have the M-15, that is the removal of methyl group. Then you have other prominent peak here, it is that M-29. This is very characteristic peak of alkynes, especially terminal alkynes. Terminal alkynes. So M by Z value M-29 or M by Z value 39, that is represents propargylic acid. Propargylic acid, that it is a very prominent peak here. And the other one you have that M-1 peak. M-1 peak means here you have the pentane molecular unit, that is mass is that you have 68, and that is 68 minus 1. So one mass unit always it represents the represents that is a proton loss, okay, hydrogen loss. So that is you have here M-1 peak, okay, that is 67, and M-15, that is 53. That M by Z value 53 represents, okay, that is loss of CH3, and then you have M-29 peak, okay, and which gives you propargylic acid. So one pentane structure, you know, right here. So here you will have CH3, okay, CH2, this is CH2, C, triple bond, CH. 5 carbons will be there, 5 carbons, and in this structure we have 3 carbons, 1, 2, 3. 3 carbons are there, and 2 carbons are removed here in this. From this here, if you see the pentane, 2 carbons are removed as CH3 and CH2. CH3, single bond CH2, the molecular weight will be of minus, that is 29. So from one pentane, CH3CH2 is removed as a radical, and you have the propargylic acid. And whereas here, CH3, that here CH3 and CH2 will be there. One of the CH3 is removed as a minus, that is 15. You will have the here M by Z value 53, and here you have the loss of one hydrogen, that is M-1 peak, okay, 67. These are the characteristic features of the mass spectrum of, okay, alkynes. Okay, so here that what we discussed, okay, that is terminal alkynes. So now here it is not a terminal alkyne, okay. So and in this case, if you see that, okay, in this case if you see here, it is not a term, this is not a propargylic acid, okay, that not propargyl cation, this is not a propargyl cation. Here basically in 2-pentane you have the loss of the prominent peak, it has become here, if you see that prominent ion, it has become molecular ion, and then M-15 it has become second mostly abundant cation here, fragment here in 2-pentane. That means that the triple bond, it will be at the second position between the second carbon and third carbon. So total 5 carbons will be there, and here the triple bond is between the second carbon and third carbon. Okay. And here if you see that 1-pentane, so this is how you differentiate. In last slides we have seen how to differentiate whether it is a cycloalkene or it is a terminal alkene or not. So that also we have seen, the prominent peaks we have seen, and their abundance also we have seen. In the same way, when it comes to alkynes also, so we should be able to differentiate. Okay, here we will not be having the terminal alkynes. Okay, only straight chain alkynes will be there, and this is a terminal alkene. So here we will have the total 5 carbon atoms, and of the 5 carbon atoms, okay, so first peak, if you see that here also M-1 value is very prominent. Okay, M-1 is a very prominent peak, and molecular and peak will be there anyway, but it's not that intense compared to the M-1. Then you have the M-15, that is also prominent, but there is a characteristic peak, okay, in straight chain alkyne, that is M by Z value 39. And now coming to the 2-pentyne. So here the triple bond will be between total again anyway one more carbon atom is missing in this structure. What I have shown, it is a fragment ion. It is not a complete structure. What I have written also here, it is a fragment ion. This is, it is not a complete structure. So coming here, so this is a fragment ion. This fragment ion is loss of one carbon unit, that is methyl unit. So and M minus 15 value it will become, but you can see here it is, there is no propargylic cation. Okay, propargylic cation M minus is not that prominent. Anyway, you have here M minus value 39, but that is not. So which is the most prominent peaks here? One is M by Z value 68. Okay, M by Z value 68, that will be molecular ion will become very prominent, because, and next one is that M by Z value 53. M by Z value 53, this will become very prominent, but this can be resonance stabilized. Okay, that's why we have here M minus once if one of the carbon atom is removed, and then this can be resonance stabilized, more stable. Okay, so that's where you have the second most prominent fragment ion here. That is how we differentiate. Okay, so terminal alkyne, and whether it is a terminal alkyne or not. Next, aromatic compound. Okay, so aromatic compound, anyway, this aromatic compounds, for example, benzene, for example, if we take the benzene, it is a aromatic compound and it is highly resonance stabilized. Okay, so you will have the very prominent molecular ion peak in this, and sometimes you may observe M+1 peak or M+2 peaks. Okay, so that is because of isotopes present. Okay, isotopes, because of the isotopes, whether it is C13 or okay, whatever it may be. Okay, and if it is a benzene ring is a saturated one. Okay, so this is especially benzene is a substituted one. Okay, with the alkyl group side chain, if it is substituted, then you will have the benzyl cation, and this benzyl cation M by Z value will be of 91. This is very prominent peak, so you can easily differentiate that. Okay, so this is a very prominent peak in the mass spectrum, benzyl cation, whose mass is that M by Z appears at a mass value that is 91. That, and it is a tropylium cation. You can call also tropylium cation, and maybe later this may be okay, and then again you will get M by Z value 65, and from this tropylium ion acetylene will be removed as a neutral molecule. Okay, so that's how it will be. So in aromatic compound, once coming to the aromatic compounds, okay, so the aromatic compounds molecular end peak is sure that it is a very prominent peak, and sometimes you'll have the M+1 peak, M+2. Okay, and then if it is substituted benzene, then benzyl with the alkyl group benzyl cation, you will get M by Z value is 91. This is very prominent peak, and then this benzyl cation, it rearranges. We have discussed that in the scrambling rearrangement. Okay, scrambling, we have discussed how tropylium ion will be formed, and this tropylium ion further it undergoes the fragmentation, and during the fragmentation of tropylium ion, acetylene will be removed as a neutral molecule, and remaining fragment appears at M by Z value 65. M by Z value 60. This is there. This is also becomes prominent. So in substituted benzene or in substituted benzenes. So if it is a benzene, you can find out molecular and prominent one, and M by Z value 60. That is M by Z value. And if it is substituted benzene, then you'll with the alkyl group M by Z values 91 and M by Z value 65. This also you can observe. Okay, so this is how here. Okay, so aromatic hydrocarbons, so you will have a strong M+1 peak. Okay, M+1 peak, and then you'll have the M-1, that is M-1 peak, that is for the tropylium ion. Okay, so and substituted benzenes can undergo, that is another one. So substituted benzene can undergo McLafferty rearrangement. Okay, And here, this is how you have here. It is a substituted benzene. Okay, substituted benzene. And here, the substituted benzene, it can undergo the McLafferty rearrangement, and there will be loss of one. Okay, so there will be loss of one proton. So, and here, that is a -1 peak you have here. This is a toluene. Toluene, if we take, and it undergoes the scrambling, that is rearrangement. Then you have the MZ value, that is represent 91, represents the tropylium ion. Okay, tropylium ion. And then here again further tropylium ion undergoes the fragmentation, and acetylene will be removed as, okay, neutral molecule, and you have the cyclopentane fragment. And further this, from this acetylene again it will be removed. Okay, acetylene will be removed, and MZ value 39. So that is cyclopropane fragment ion. Fragment ion. This is how the fragmentation takes place in the substituted benzene. Okay, substituted benzene. So in that is aromatic hydrocarbons. So molecular ion will be very prominent, and if it is substituted like toluene you have, and fragmentation takes place, and then you will have the very prominent peak. This tropylium ion, which appears at ambassador value 91, and this one further undergoes the fragmentation, which gives another fragment ambassador value 65. This ambassador value 65 is because from this there is a loss of neutral molecule, that is acetylene, and another peak you will observe, okay, in aromatics, that is ambassador value 39. Again, that is because another, again you have the loss of acetylene. Successive loss of acetylene molecules will be there, and first one is ambassador value 65. Another loss of acetylene, it will be the ambassador value 39. Okay, so this is with the aromatic compounds. So benzene, okay, molecular weight, where you have the molecular weight is very prominent peak. Okay, this is a very prominent peak you can observe, molecular ion peak benzene, and these are the very less abundant ions. But in benzene, if you see, it undergoes the fragments, but we are not much concerned about that. So these are another fragment peaks. Here we can see that, okay, ambassador value 78. So this 78 is very prominent peak benzene, because it will not undergo that extensive fragmentation. Understood? Benzene will not undergo that extensive fragmentation. So benzene remains as such, and molecular and only majorly molecular ions only will be reaching to the detector. So that's why ambassador in benzene, the ambassador value, that is 78, is most abundant ion, and the most abundant ion for the benzene is ambassador value 78. This ambassador value 78 represents the molecular ion. So molecular ion becomes 100% here. Okay, intensity of molecular ion, and it will not undergo that fragmentation. Understood? So this is, so next toluene. So toluene, if you see that you have the molecular ion, and that is the molecular ion value here, toluene, if you see, that is 92, and next one is that ambassador value you have, that is M-1 value, and this is ambassador value 91 is for the tropylium ion. You can see I told you the 7-membered stabilized ring, tropylium ion. So toluene undergoes loss of that is M-1. Okay, and you have that is because of the McLafferty rearrangement. And then here you see ambassador value 91. This is very prominent peak in mass spectrum. So you can see here ambassador value. This will become 100% in toluene, and then 91, it represents the tropylium ion. So okay, and from tropylium ion there will be loss of acetylene. You will have the ambassador value 65, and from this again, okay, so further there is a loss of another acetylene, ambassador value 39. These are the major prominent peaks in here in substituted benzene like toluene. So here how it takes place, the formation of a tropylium ion. Okay, so tropylium ion, you can see that here there is a cleavage here. Okay, substituted benzene, there is a molecular ion, and here there is a cleavage. As I already told you, substituted alkanes always happens at the beta carbon atom. Beta carbon atom cleavage occurs at beta carbon atom, and then once it is removed as a radical, then you have the benzyl cation. Benzyl cation further, okay, through the scrambling, okay, we already discussed, and it forms a 7-member tropylium ion, and you have the M by Z value 91. This is highly resonance stabilized. Okay, than this is highly resonance stabilized. Okay, this is how you represent 7-member tropylium ion, and this tropylium ion further fragmentation. Okay, what is the further fragmentation? M by Z value 91 appears. So then, how you count for these peaks? Okay, M by Z value 65, M by Z value 39. How you count for these two peaks? Okay, so how we account for this? So tropylium ion M by Z value 91 is there, and this 65, okay, M by Z value 65 is represents loss of, okay, one acetylene molecule as neutral one, and cyclopentanium ion you will have. And then further M by Z value you can account for by further the cyclopentanium ion losses. Okay, it loses one again further that is acetylene, and you'll have the M by Z value 39. This is how you account for all the peaks which are appearing in, okay, substituted benzene. The prominent ion peak, whereas benzene, if you see that the prominent ion peak, you have the, okay, by Z value 8. That is how you account it. Whenever you see 78 and it is highly prominent, okay, and 100% molecular ion peak, it is a benzene. There is no other doubt in that. Next one is that this toluene, substitute benzene, M by Z value 91, you find out, okay, M by Z 91, and then there definitely is a tropylium ion. So tropylium ion comes from where? So if you have a substituted benzene, so where benzene is substituted with the alkyl group. So when alkyl group is substituted, and at the beta carbon atom cleavage takes place, and further it undergoes the rearrangement, then you have the tropylium ion, and tropylium ion in substituted benzenes, you have other less abundant peaks, but it is M by Z value 65, M by Z value 39, and so that's how you account all those peaks. Okay, so M by Z value 65 is because of the loss of acetylene from the tropylium ion, and then you have the M by Z value 39, that is loss of acetylene, the cyclopentanium ion. So these are how you account for all the peaks that are present in the mass spectrum of substituted, that is benzenes, alkyl substituted benzenes. So next, ethyl benzene example, I have given you there, ethyl benzene. Okay, and the toluene I have given, this is ethyl benzene, and ethyl benzene molecular weight you can see there, M by Z value molecular and, okay, molecular ion peak. So M plus peak, you can call it as M plus peak at 106. Okay, that's molecular weight, and then here 91. Okay, M by Z value, that is because of loss of CH3, and benzyl cation, it undergoes the scrambling tropylium ion, and then M by Z value 65, loss of acetylene, that is M minus 6, M by Z value, okay, 26, and then here again further loss of another, okay, 26, the acetylene molecule from 65, 26, that is 65 minus 26, you have the, okay, here cyclopropylium ion. So these are how I account for that. So butyl benzene, okay, butyl benzene, and as I told you, so here they also can undergo the McLafferty rearrangement. McLafferty rearrangement, M by Z value you can see here, substituted one, okay, substituted one, you can see M by Z value. So butyl benzene, this is butyl benzene, and M by Z value molecular and peak is appearing at 134, and then there is a McLafferty peak, okay, M by Z value 42, that is, and then 92, M minus value 92, that is 92, and here there is a tropylium ion. Again tropylium ion for substituted benzene, substituted aromatics, that is especially benzene, and M by Z value, that is 91, is the prominent peak. Okay, is the prominent peak, so that you can account. Okay, so further you can 65 will be there, again you have 39 also will be there. So those peaks, but the prominent peaks, if you see that the molecular ion and M by Z value, but here how do you account for M by Z value 92? That 92 we have not observed some here or anywhere. It is there, but we cannot, we didn't observe. Okay, that it is not that prominent peak. But here this is very prominent, M by Z value 92. So this 92 is because of the McLafferty rearrangement. You can see how the McLafferty rearrangement happens here. Okay, McLafferty, the gamma hydrogen will be there here. So the gamma hydrogen removal, okay, gamma hydrogen will be there, and then you will have the removal of this. Okay, you can see olefin as in McLafferty rearrangement. We know that in cation plus neutral, olefin will be removed. So there is a removal of olefin here. You can see that olefin will be removed, and this is the olefin you have. The loss of that, it will be there. So this is how you account for the M by Z value 91 because of the McLafferty rearrangement. So today with this, we finished with the aromatic compounds, and still now we have seen that alkanes, and in alkanes we have seen straight chain, branched cycloalkanes, and then you have the alkenes. In alkenes we have discussed about terminal alkenes, and alkynes we have also discussed, and terminal, how you differentiate whether it is a terminal alkyne or not, and how to differentiate whether it is terminal alkene or not, and cycloalkenes also we have discussed. Okay, so what are the prominent peaks and their M by Z values, how